So switching to the demo. Let's build the chat application. Chat application is when we have different people, and people can send real-time messages, and other members of the chat can see these messages in real time. So first of all, let's decompose the chat application into a set of services. For the simple chat, we have just two services. The first service stores messages of the chat so that a person who joins later can see the history. It's the chat history service. And we also have the user list service to have all the users and to notify them about the new messages. Here we have the same on the network map. We have clients. For example, this client in a browser. We have two peers, and we have a service for the user list, which stores members, and we store messages in the history service. How could the composition, what could the composition look like? When the client sends the message is stored to the history service. Then in order to broadcast the message, we need to fetch users which are the members of the chat. We have the list of users, and then we call the function to display the message on all the other clients. So let's take a look how it works. Here we have the chat application. I'm already joined. I'm a zebra, and I can say like something. Here we have an error script that was emitted to the network and executed by the Fluence nodes and by the other peers who joined the chat as I did. And I can reply to some message, send a reply to the folks that loves Fluence. Nice. So here's the reply. So nice. And actually it was coded just in a couple of hours. But what is even better is that from the chat app, we can do, for example, a feed app or a channel app. For example, in Telegram, we had these channels when we have messages from a particular author authorized to send messages, and we have many subscribers to get these updates. So essentially, feed is the chat with the authorization check, so that we still can use the user list service for subscribers. We can take the chat history service for messages and change it to make up the feed history service by adding some part of authorization here. And if we wrap up these two services and deploy them again, we will have the new application, the feed application. The interaction here is very similar. The only change is that we store posts in history, we store subscribers in the user list, and here we check if the client that tries to store the post is the owner of the service. And then we have the same interaction for broadcasting posts. Let's take a look on the demo. Here we have the feed. I'm the camel. And here we have only posts from the camel. I can add the post as a camel. It's handled with just the same air script, and I can add data here. I can spread my thoughts to the world. Nice. Finally, let's take both and let's augment the feed with comments to have the blog application. So blog essentially is the feed or a channel with comments. And to make the blog, we can reuse the chat history service to store comments here and to make comments history service. And we can reuse the already deployed feed application so that there we already have the author, we have links here, we have content, and we just want to extend this open application with comments independently. So the network map will look like this. We have all the same services from the feed application, which were already deployed. And we deployed a new service, history service, for the comments. We can store comments like replies to the posts stored here. We can get comments. And we still have all the other interactions. We check the owner and so on, and the old UI still works. The old application still works. We still have activity of authors here. We still can send the posts. We still broadcast posts. Just add some new UI for the comments. Let's take a look on the third demo. Here we have the same feed, the same content, but now I'm not authenticated as the camel. I'm not the author that can send messages, so I don't see this at post fragment. But if I say something, it will appear here. But now I can choose the post, and I can add a message as a monkey. Hi, I'm a monkey. Send a comment, it works. Oh, and we have some other comments here. Hello, camel. Hi there. So to handle this, we slightly changed the error scripts and reused the previous deployment of the feed application. So it was pretty easy. But finally, we have two different applications, two different layouts, reusing both code and the data and the users. So just to recap, I demonstrated a full stack application. We have front end and we have back end. For the front end, I used Helm UI, and I have arrow scripts. So the choreography is expressed on the front end, and the scripts are emitted, sent to the network to be executed. For the arrow scripts, we have a Fluence JavaScript SDK, actually TypeScript SDK. And we run WebAssembly error interpreter in the browser. So it's the same code on the front end, on the back end for interpreter. Just to recap, error is a Korean intermediate representation, a low-level language. On the back end, we have deployed several Fluence nodes. We use Kademlia under the hood to find the peers by public keys. We use DHT to register peers and relays and to route to clients, from clients to clients. And on every node on the backend, the Fluence compute engine is being running. It runs air interpreter compiled to WebAssembly, and it's running in FCE. And then we have multi-module services for history and for user lists. Each is built from SQLite compiled to WebAssembly and from some business logic. This demo is available on GitHub. You can take a look on Air scripts and you can try to compile it, file issues, and so on. And also we have Fluence, FCE, and Aquamarine source code opened. You can take a look on it. And finally, this demo is live right now. If you open this link, you will see the chat that I was using just recently. So let's play with it. And if you have any issues, please file them.